morning, students. Welcome to Elimu Live mathematics lesson for Form 1. And today we are discussing a topic called angles and plane figures. Welcome and be ready to participate in our lesson. Now, last time we were looking at angle properties of a circle, and we discussed various properties that relates to the circle. But there is something that we call angles and plane figures, where we need to see how angles are related in different shapes. But more importantly, for today's lesson, we are discussing what we call angles on a transversal. When we talk of a transversal, what do we mean? Now, in your primary school mathematics, you must have been introduced to what we call parallel lines. And do you remember what are parallel lines? Parallel lines are simply lines that do not meet when they are drawn in the same dimensional plane. What I mean is that we have different dimensional plane in mathematics. For high school, look at the two-dimensional plane and three-dimensional plane to some extent in Form 4. But for this case, when we draw two lines, let's say in the two-dimensional plane, and those lines fail to meet at a point, then those lines will become parallel. We insist that it has to be the same dimensional plane, because at times you may find a line drawn in the two-dimensional plane and another one drawn in the three-dimensional plane. They may appear parallel, but they end up meeting at a point. And so in that case, they fail the test of parallel lines. So parallel lines are simply lines that do not meet when they are drawn in the same dimensional plane. And so these lines, when we draw them, we have something that we call a crossing line. For example, if I have the line P and Q, the line PQ and the line RS, line RS. So these two lines are parallel to each other. And the reason is that they do not meet at any point. So we say that these lines are parallel. And we denote parallel lines using the arrows. For instance, in this case, you find that we have these arrows indicating that these two lines are parallel. Now, when I draw another line, let's say this is the line XY. The line XY, or I draw another line at this point. Let's call this line AB. The line XY and the line AB, these lines are what we call transversal. These are transversal. When we talk of a transversal, this is simply a line. This is a straight line that cuts two parallel lines. So when you have two lines that cuts across two parallel lines, then we call those lines transversals. So angles on transversals are then determined on this kind of a situation. We have different angles that I want us to discuss that are formed on a transversal. And I will name these angles. Let's say we have the angle A with the angle B, the angle C, the angle D, and then have E, F, G, H. And I can do the same for the numbering of A, B. These are the angles that we are calling the angles on the transversal. So angles on a transversal are in different ways. We look at four main angles on a transversal with what we call the vertically opposite angles. Vertically opposite angles. Students, when you talk of vertically opposite angles, the simplest demonstration is when you take your hands and you cross them. Then there is a set of angles that are formed, one at the top and the one at the lower side. These are what we call the vertically opposite angles. In this case, let's look at the angle, for example, the angle A and the angle C, with the angle D and the angle B. So we have A and C, D and B. Equally, at this end, we have E and G, then we have H and F. These are vertically opposite angles and they are equal. When discussing vertically opposite angles, they are always equal. So if, for instance, this is 40 degrees, then I expect C again to be 40. If I have this as 70, then this will be 70. If this is 50, this will be 50, because they are always equal. So that's the first set of angles, vertically opposite angles. Number 2, we will discuss what we call straight angle. A straight angle is simply, or straight angles are angles that are on the same straight line. And these angles always add up to 180 degrees. Or in other words, they are supplementary. Straight angles are always supplementary, meaning they add up to 180 degrees. Like if we look at this line PQ, now we shall have the angle D and the angle A on the same straight line PQ. So for instance, on line PQ, we obtain the set of angles D and A. D and A are straight angles. C and B are again straight angles. If I look at now the line RS, looking at the line RS, RS now will give us the angle H and the angle E, H and E, and G and F, G and F. Those are straight angles. Equally, we can look at the line XY. If we consider XY, which is the transversal, then we'll have the angle GH, so G and H, then have EF, E and F. At the other side, we have D and C, then A and B. So this set of angles are supplementary, and they add up to 180 degrees. So if, for instance, we give you angle D is 20, then using that logic, angle A will definitely be 160 degrees. That is 180 minus 20 degrees. So that is our second type of angles on the transversal, what we call the straight angle. Number 3, we want to discuss what we call the Z angle. The Z angle, also called the alternate angles. Now, we call them Z because they tend to form a letter Z. So looking at our diagram, with P, if you look at P, up to this point, then we drop along the transversal up to this point and take this turn to the side of S. That is a letter Z. So we've obtained the angle C and the angle E. These are what we call the alternate angles. That angle C alternates to angle E. So we'll say here that E alternates to angle E. If we look at the extension of this Z, if you take this turn to this point, to this point and again drop this way, you'll find letter B and letter H will also be there by extension. So if B alternates H. And alternate angles are always equal. The rule is that for all alternate angles, they are always equal. So when you summarize the alternate angles, they are in the Z letter, then we say that those angles are equal. After looking at the Z angle, the last type of angle that we look at is what we call corresponding angles. Corresponding angles. And students, I want you to understand, how do you identify the corresponding angles? Because in this case, mostly what we think is corresponding does not actually correspond to any angle. If you want to identify correctly corresponding angles, the first thing that you must ask yourself, what is the line that you are putting as a considering line or as the baseline for you to determine the corresponding angle? This is what I mean, that we have two lines here, PQ and RS, and then we have the transversal. Give these angles positions. If I look at the line PQ on the left side of the transversal, the first angle is D. Again, I'll repeat. If you look at the line PQ on the left side of the transversal, the first angle is D. So what is the first angle on the line RS, the same side of the transversal? It's angle H. So H and D are in the same position on the same side of the transversal. Therefore, D and H corresponds. That is number one, that D and H, because they are on the same side of the transversal in the same position. Number two, on the right side of the transversal, what's the first angle? Angle A. If you look at line RS, on the same side of the transversal, the angle is E. Therefore, A and E are in the same position, and therefore they correspond. So we have A and E. We go to the next thing. Go back to the line PQ. PQ, the first angle on the lower side, on the left side of the transversal, is C. The same position looking at line RS is taken by the angle G. Therefore, C and G correspond. C and G will correspond. Move to the other side again and look at the second angle on the other side is angle B, which then corresponds to angle F. So B and F. And all corresponding angles are equal. A pair of corresponding angles are equal. That means that angle D is equals to H, angle A is equals to E, angle C is equals to G, angle B is equals to F. And the reason is they are corresponding angles. And remember last time we said topics to do with angles require you to give reasons. So if you have to be given a question on this, we expect you to be able to write down the reason as to why your answer will be the value that you'll have obtained. And the reasons that we will be giving will be based on either the angles were vertically opposite angles, they were straight angles, Z angles, or they were corresponding angles. But all this out, if you want to look at it carefully, you find that there is something that we've not mentioned. And this is what we call angles at a point. That angles at a point add up to 360 degrees. So if you take the angle D, A, B, and C, sum them up, you get 360. Angle H, E, F, and G, sum them up, you get 360 degrees. So that is briefly what we call angles on a transversal. Just hint to know that a transversal is a straight line that cuts two parallel lines. And this transversal gives us 4 sets of angles, what we call the Z angles or the alternate angles, corresponding angles. We have vertically opposite angles and the straight angles. Now, once we've looked at this summary, then it's important that we look at one of the most common part of this topic, what we call the polygons. So we look at now what we call polygons. So the question is, what is a polygon? What is a polygon? A polygon, just like any other figure or any other plane figure, is simply a figure that is bounded by more than 2 lines. A figure that is bounded by more than 2 lines. Remember, if I have this line and this line, when these 2 lines bound or they meet at a point, what is formed is an angle. If I just draw this, I've obtained an angle. But now when I bound this with more than 2 straight lines, I now start seeing figures. I'll repeat. When you have this topic, angles and plane figures, draw 2 straight lines meeting at a point. We obtain an angle. When we join, we now make it 3 lines. We now obtain a plane figure. So a polygon is simply a plane figure that is bounded by more than 2 straight lines. And the simplest polygon is a triangle. A triangle is a polygon with 3 sides. And so if we can be able to tell that a polygon is bounded by more than 2 straight lines, then we have what we call common polygons. Common polygons that are named based on the number of sides. These ones are named based on the number of sides. On the number of sides of the polygon. And so let's draw a table and be able to identify these common polygons with their names based on the number of sides. So I'll have here number of sides, and then I'll have name of the polygon. And we start with the lowest number is 3. We go to 4. We go to 5. We go to 6. We go to 7. We go to 8. We go to 9. And lastly, a polygon with 10 sides. So again, I'll ask my students to give me the name of a polygon with 3 sides, because we've just discussed it before. How do you call it? We call it a triangle. So when you ask what's the polygon, the name of the polygon with 3 sides, it is a triangle. The challenge becomes when it's 4 sides. Students will say it's a rectangle, some will say it's a square, some will say it's a rhombus, a parallelogram, a kite, and such kinds of names. But those are not the exact names. All those that we've been able to name are in the group we call quadrilaterals. So polygons with 4 sides are called quadrilaterals. That includes the rectangle, the trapezium, the square, the rhombus, the kite, and the parallelogram. A polygon with 5 sides, pentagon. That is common to most students, the pentagon, 5 sides. 6 sides, hexagon. 7 sides, to those who are in sports will be able to tell, 7 events and 10 events. Heptagon. heptagon. 8 sides, we call it an octagon. 9 sides, we call it a nonagon. And 10 sides, we call it a decagon. Those are the names of quadrilaterals based with the number of sides of each of the polygon. So if you are told to name, maybe you have a question that required you to calculate the number of sides and you got 5, and you ask the name, then you'll be able to tell the name of that polygon is a pentagon. If you're looking at 6 side hexagon, 7 sides heptagon, 9 sides nonagon, 10 sides decagon, and that is the maximum that we can name for high school. But we still have names for polygons that may be going above 10. But for the case of our syllabus, we only get to 10. Now, I've said that a polygon is bounded by more than 3 straight lines. Assuming this is my simple polygon with ABC. And this polygon, it has angles. With the angles here, let's call this angle A, angle B, and angle C. Angle A, B, and C are within this polygon. They are inside the polygon. We refer to them as interior angles. Angle A, angle B, and angle C are called interior angles. They are called interior angles. And the reason is that they are within the polygon. If I produce by extension line AB, I produce this side, I obtain an angle X. If I do the same production on this side, I'll obtain the angle Y. And I can as well do the same on this side and obtain the angle Z. Then you find X, Y, and Z are not within the polygon. They are out of the polygon. These angles are referred to as exterior angles. So angle X, angle Y, angle Z are called exterior angles. They are called exterior angles. Looking at our polygon, of which students should be able to tell that this is a triangle, but we are using the polygon for the sake of all of these polygons. This polygon has the exact number of sides, and we tend to believe that all these sides are equal, that all the sides are equal, assuming that this side, and this side are all equal. And then it definitely tells you that these angles inside this polygon will also be equal. Because in a triangle that has all the 3 sides equal, it's referred to as an equilateral triangle. And all the angles are 60 degrees. So if you find a polygon whose sides are equal, definitely the angles are going to be equal. Then we refer to this polygon as what we call a regular polygon. A regular polygon. In a regular polygon, it has what we call a same, not same, but really equal number of sides. Equal number of sides. So in terms of the length, that these sides are always equal. And so when you calculate anything in relation to a regular polygon, there is what we call formulas that we need to adopt. And these formulas are based on either interior angles or exterior angles. If we all look at the angle A and angle Y, what can we say about them? Angle A, angle Y. Angle C against angle Z. angle B, and angle X. What can we say about them? Based on the earlier understanding of angles on a transversal, you'll tell that angle A and Y are on a straight line. Angle C and Z are on a straight line. Angle B and X are again on a straight line. And if they are on a straight line, we said the sum of those angles is 180 degrees. So it means, therefore, that angle A plus angle Y is 180 degrees. Equally, angle B plus angle X is 180 degrees. Angle C plus angle Z is 180 degrees. This is based with the numbering of A, B, C, and X, Y, and Z. But the question is, in terms of interior and exterior, how do we now explain these two cases? It is very simple, that A is an interior angle, Y is an exterior angle. B is an interior, X is an exterior. C is an interior, Z is an exterior angle. Therefore, it concludes as that if you take an exterior angle plus an interior angle, you'll always get 180 degrees for all regular polygons. That the exterior and the interior are supplementary. Good. In terms of interior angles, how do we relate the interior angles? For interior angles, we have two formulas that we will be applying. We have two formulas that we'll be applying. Number one, we have what we call sum of interior angles. Sum of interior angles. Now, assuming that these angles are 60, 60, 60, then the sum of angles in this polygon is 180 degrees. So if you are to calculate the sum of interior angles, we have 2n less 4 right angle. And in this case, we say n is the number of sides. Number of sides. So let's see, in this case, this polygon has 1, 2, 3 sides. So if I replace in, I'll have 2 times 3 less 4, then by 90. This is 6 less 4, that is 2. 2 times 90 is 180 degrees. And it is true that sum of angles in a triangle is always 180 degrees. Similarly, sum of interior angles will always be given by theta n, where is theta here is simply one interior angle, and n is the number of sides. Number of sides. So if you have, for example, you are told one of the interior angles of the regular polygon is 40, and the polygon has 7 sides, then you simply take 40 times 7 to get the sum of interior angles. Then we are going to apply the formula that when talking about an exterior angle of any regular polygon is 360 degrees divided by n, where n is the number of sides. This is based on the understanding that sum of exterior angles is 360 degrees. So we have listed down these formulas that I want us to apply. We have this formula where we're looking at the exterior plus interior is 180. we've now listed down this formula here, sum of interior angles. Again, sum of interior angles is theta n. An exterior angle is 360 over n, and then we've said sum of exterior angles is 360 degrees. These are the principles that we want to use to work out few questions in the topic angles and plane figures. Now, when the questions are set in this topic, then you've to be careful that questions will always be on this area when you talk of polygon. And I will give 3 questions that you can be able to analyze in this part and see how we work them out. The first case is quite simple. You're told the sum of interior angles of a regular polygon is 1800 degrees. You're told to find the number of sides of the polygon and the size of each exterior angle of the polygon. The sum of interior angles of a regular polygon is 1800 degrees. We are told to find the number of sides of the polygon and the size of each exterior angle of the polygon. With the basics we've discussed, I believe wherever you are, you can be able to work it out on your own. However, let's be able to work it together. This is the formula, that the sum of interior angles is this, or this case. But we cannot apply number 2 formula. Why? Because one of the question asked is theta. So we don't have theta and we don't have n. So what we have to look at is work out with the first formula, that the sum of interior angles is 2n less 4, 90. So you simply replace, substitute, expand that to have 180n less 360 is equal to 1800. So you collect the like terms. This to the right side we have plus. So 180n is equal to 2160. Divide this by 180, divide this by 180. So that this cancel out. This cancel out. 2 is 9. 2 at this point is 10, 8. 9 here is 1. 9 here is 1. And this is 18. That is 12. So it means n is 12 sides. So how many sides? 12 sides. If the polygon has 12 sides, then what is the size of each exterior angle? We've said that the exterior angle is 360 divided by n. So what will this be? 360 divided by 12. That will give you 30 degrees. So each exterior angle is 30 degrees. Now, assuming we now brought in a case to say we find the interior angle, then what will be the case? If we are asked about the interior angle, then we'll say the exterior plus interior is 180 degrees. So this will be 30 plus the interior will be 180, implying that the interior angle is 150 degrees. So if you get to understand the formulas, all the formulas, then it is easier to work out each and every question that will be given. So that is case 1, where you are given the sum of interior angles as a direct value. If you not be given this case, then what we expect to have a different case application of algebra. And since angles and plane figures comes after algebra, you should be able to interpret this question. You're told that the size of each interior angle of a regular polygon is 6.5 times the exterior angle. And the question is, find the size of each exterior angle, and hence the number of sides of the polygon. And hence the number of sides of the polygon. So students get there, they get stuck. They wonder now, what do we do? The question has only 6.5 times, so no working. If you give them 1800, they will be able to say, this is a question that has numbers. But now when you bring it this, they tend to say, we have no question to work out. But there is indeed a question to be worked out in question 2. We are only applying our understanding on algebra and bring it to plane figures and see how it works out. If you look at this case with the interior and exterior, the interior is 6.5 times the exterior. Definitely it means that the interior is larger than the exterior. So we give the less angle or the smaller angle the unknown. So we'll say, let the exterior be x degrees. Let the exterior be x degrees. So what will be the interior? The interior angle will be 6.5 times 6.5 of x. And since we have the exterior and the interior, we go back to the reflection of the relationship between the interior and the exterior. We said that if you take an exterior plus an interior angle, the answer should be 180. So it means 6.5x, add x, gives you 180. In other words, this is 7.5 of x is 180. And divide this by 7.5, divide this by 7.5. So that this cancels out. So x simply means 1800 divided by 75. If you divide by 5 at this point, this is 1, 15. 5 in this case, 3, 30, that is 60. If you divide again by 15, this is 1. 15 into 36, it is 2 because of 30. We are left with 6 into 60, that is 4. So our x is 24 degrees. Our x is 24. And then we ask ourselves, what is x? X is the exterior angle. So it means our exterior angle is 24 degrees. Our exterior angle is 24 degrees. So we've worked out one of the question because we are told to find the size of each exterior angle. And how many sides does this polygon has? We said that the exterior angle is equal to 360 degrees divided by the number of sides. So if you make the number of sides the subject of the formula, then it implies the number of sides will always be equal to 360 divided by each exterior angle. By simplification, 12 is 2, 12 is 30, and so our solution is 15 sides. So this polygon has 15 sides. That's how we work it out when you're given the unknown and when you're given an exact figure in the question. And so let's look at a third way in which this question could be given to you. Number 3, you're told that the size of each exterior, the size of each interior angle of a regular polygon is the size of each interior angle of a regular polygon is 30 degrees larger than the exterior angle. Then you're told to find the sum of interior angles of the polygon. The size of each interior angle of a regular polygon is 30 degrees larger than the exterior angle. Find the sum of interior angles. We now have the interior, we have the exterior, and now we are asked the sum. In the first case, there was no sum. But in question 1, we were given the sum with a value. These are the same questions, but they are worked out differently using the same formulas. So we'll say we let the exterior. I'll again say let the exterior to be x. If you compare question 3 and question 2, there is a difference. The interior here is 6.5 times the exterior, but here it is 30 degrees larger. So we'll then mean that the interior will be x degrees plus 30 degrees. Do not be confused and write 30x. It is simply 30 degrees larger than the exterior. So you simply take x plus 30, and that is the interior angle. So what is the sum? We said that the exterior, again plus the interior, is 180. So definitely x plus 30 is 180 degrees, implying that 2x is 150, and so x is 75 degrees. And x is the exterior angle. So how many sides does this polygon has? We say n is 360 over the exterior. 360 divided by 75. 360 divided by 75. Let's divide by 5. This is 15. By 5, this is 6. Sorry, this is 7. And then we are left with 1, 2. We divide this by 3. This is 24. Divide this by 3. This is 15. So we have 24 divided by 15. 24 divided by 15. Sorry, let's do the division again. We have 360 divided by 75. 5, this is 1. 5. By 5, this is 7. Into 10, that is 2. So we have 72 by 15. That is 15, here is 1. 15, that is 4 because of 60. We are left with 12 into 120, that is 8. So 0.8. So now when you have the answer is 4.8, what do you write? We can't have a polygon with decimal number of sides, so we round off to the nearest whole number using the simple, this simple, so that gives us 5 sides. That means that the value has been rounded off since these are number of sides of the polygon. And so once we have 5 sides, then how do you tell sum of interior angles? Sum of interior is that is 6 theta times n. Our theta should be the interior angle. So our interior angle is simply 180 minus 75, and that should give us 105 degrees. Therefore, sum will be 105 times 5. 105 times 5, that gives us 5 because of 25, and then that gives us 25 degrees as sum of interior angles. So that is what we have to look at in the topic angles and plane figures. So in summary, this is what we've discussed. One, we've discussed what we call angles on a transversal. Angles on a transversal. And if you are asked what are the angles on a transversal, where transversal is simply a straight line that cuts two parallel lines, then we've listed down what we call vertically opposite angles. Vertically opposite angles. And the rule is that all vertically opposite angles are equal. We've mentioned what we call the straight angle. They add up to 180. We've mentioned what we call corresponding angles. Corresponding angles are equal. And then we will mention what we call alternate angles. Alternate angles, or the Z angles. Number 2, we've discussed what we call polygons. And we've said that a polygon is simply a plane figure that is bounded by more than 2 straight lines. And we've been able to name the polygons based on the number of sides. We've mentioned what we call triangle. A triangle is a polygon with 3 sides. This one has 3 sides. We've mentioned a quadrilateral. A quadrilateral being a polygon with 4 sides. A pentagon being a polygon with 5 sides. We've mentioned a hexagon. A hexagon is a polygon with 6 sides. We've mentioned a heptagon. A heptagon being a polygon with 7 sides. We've mentioned an octagon. An octagon being a polygon with 8 sides. We've mentioned a nonagon. Nonagon is a polygon with 9 sides. And lastly, we've mentioned what we call a decagon, which is a polygon with 10 sides. These are the polygons that we've mentioned. And finally, we've looked at what we call formulas that are used to calculate angles in a polygon. We've discussed about the interior angles of a polygon, the exterior angles of a polygon. They are related by being supplementary. And sum of all interior angles of a regular polygon is twice the number of sides, less 4 times 90. And then we've discussed again what we call sum of interior angles based with the formula 6, that is theta times n. And in this case, it only happens if you are given the value of theta, and theta being 1 interior angle. So you take the 1 interior angle, you multiply by the number of sides. Maybe just one example on this formula so that you see how it is applied, and then we can wind up our lesson. So if you are given a case for this formula of theta, maybe you'll have a question and you're told that the size the size of each interior angle of a regular polygon is 135 degrees. Find, part A, you're told the size of each exterior angle. Number 2, you're told to determine the number of sides of the polygon. And lastly, number C, the sum of interior angles of the polygon. Let's use this as our last example. That the size of each interior angles of a regular polygon is 135 degrees. We find the size of each exterior, the number of sides of the polygon, and the sum of interior angles. So let's start with the first one. We have the interior. With the interior, our interior angle is 135. So to get the exterior is very simple. We say the exterior plus interior is 180. Therefore, take 180 less 135, and the answer is 45 degrees. That is the exterior angle, 45. So part A, the solution here is 45 degrees. Part B, the number of sides of the polygon. We said number of sides is given by 360 divided by 1 exterior. So you take 360 divided by 1 exterior, which is 45 degrees. 360 divided by 45, let's see, this is, that is 9 is 5, 9, this is 40. So we have 8 sides. We have 8 sides as the number of sides. This will be 8 sides. And part C, the sum of interior angles. So sum of interior angles, that's now where I wanted to explain the formula, theta times n. And we said theta is 1 interior. Therefore, you take 1 interior, which is 135, times 8 sides. So if you multiply this, you get that is 40, 24, 28, and then we have 10, 80 degrees. That is sum of interior. Alternatively, if you don't want to apply that formula, you will still say that sum of interior is twice n less 4, 90. Since n is 8, that means 16 less 4 times 90. And that should give us 14, not 14, but 12 times 90. Multiply, this is 18, this is 9 plus 1, 10, 80 degrees. So whichever the formula, you still find the same value. And it only works if those polygons are regular polygons. If you have irregular polygons, then what you are saying will not work out. So please note, it can only happen, as we explained, if the polygons are regular. With that, we come to the end of our lesson for today. Thank you for being my student today. Until next time, I've been your teacher, Mr. Ndenga-Global.